Hello everyone. Now we are starting the last part of the network layer protocol. In this part, we are learning about some protocols that are used in the transport layer. First is ICMP, that is Internet Control Message Protocol. The IP provides unreliable and connectionless datagram delivery and makes an efficient use of the network source. IP is the best effort delivery, which does not provide any guarantee service that takes a datagram from its original source to its final destination. However, IP has two drawbacks. It does not have any error control mechanism and it does not have any assistant mechanism. The Internet Control Message Protocol ICMP is used to overcome these drawbacks. It is used along with the IP. It reports the presence of the error and sends it to the control message on behalf of the IP. ICMP does not attempt to make a IP a reliable protocol. It simply attempts to report the error and provides feedback on the specific condition. ICMP messages are carried out as IP packet and therefore unreliable. ICMP is network layer protocol. IP is also lack mechanism IP also lacks a mechanism for the host and management queries. A host sometimes want to know if the router and another host is operating or the dead, and sometimes network manager need information from another computer on the network, such as host or router. ICMP operates in the network layer, but its messages are not passed directly to the data link layer. Instead of messages are first encapsulated inside the IP datagram and then sent to the lower layer. The ping commands use ICMP as the probe of the whether the station is reachable. Ping packages an ICMP echo request message in the datagram and sends it to the selected destination. The user chooses the destination by specifying its IP address or the name on the command line, such as ping 100.50.25.1. When the destination receives the echo request message, it responds by sending ICMP echo reply. If a reply is not written within the set time, the ping resends the echo request and several more times. If no reply arrives, a ping indicates that the destination is unreachable. Another utility is that ICMP trace route, which provides a list of all routers along with the path to a specified destination. There are several types of messages in the ICMP. First is error reporting message and second is query messages. First, error reporting messages. One of the important responsibility of ICMP to report the presence of an error. IP is an unreliable protocol, so error checking and controls are not done by IP. So ICMP was designed to assist the IP, but ICMP does not correct the errors. It simply reports them and leaves the error correction job on the higher layer protocols. ICMP always sends the error reporting messages back to the original source. ICMP has 5 types of error reporting messages. First is destination unreachable, source quench, time exceeded, parameter problem, and redirection. First is destination unreachable. When the router cannot forward or deliver an IP packet, it sends a destination unreachable ICMP message back to the source which originated the packet. Second is source quench message. A host or router uses the source quench message in order to tell the original source that the congestion has been occurred to request it to reduce the current rate of packet transmission. There is no flow control or the congestion control mechanism in the IP. So the source quench message in the ICMP is designed to add some kind of flow control and congestion control to the IP. This message serves two purposes. First is it tells the server किंवा source the packet has been discarded, and it gives a warning to the source that the source should slow down quench because of congestion that has taken place somewhere. Next is time exceeded message. This message generally has in two cases. First is if a source router receives a packet with 0 in the TTL field, then it discards the datagram and sends the time exceeded message back to the source originating that package. If the all fragments which are the part of a message do not arrive at the destination host within a certain time limit, then the time exceeded message is sent back. And next is parameter problem message. There should not be any errors in the header part of the packet. If the router or the destination host come across this such errors or the missing values in the field of the datagram, then it simply discard that datagram and sends the parameter problem message back to the source originating that message. And last problem in the error reporting message is redirection message. If a router or the host wants to send a packet to another network, then it should know the IP address of the next router. The router and host must have a routing table to find the address of the next router, and the routing table has to be updated automatically on the continuous basis. The redirection message is used for such updation. The ICMP sends the redirection message back to its host to carry out an automatic periodic updating. Next type of messages are query message. The ICMP can diagnose some network problems in this addition with the error reporting features. Such diagnosis is done through the query messages. There are four types of query messages: echo request and reply, timestamp request and reply, address mask request and reply, and router solicitation and advertisement. First is echo request and reply. This is the pair of two messages, namely echo request and echo reply message, and they are designed for the purpose of diagnosis. This pair of message determines whether two system, host or routers can successfully communicate with each other. Next is timestamp request and reply. This pair of message can be used for the host and router to find out the round trip time of an IP datagram need to travel between them. It can also be used for synchronizing the clock signals used in the two machines, host or the router. Address mask request and reply. The IP address of the host contains the network address, subnet address, and host identifier. A host may know its full IP address but may not know it's divided into three parts mentioned above. So it can send an address mask request message to the router, and router then sends back the address mask reply message. And last is router solicitation and advertisement. A host that wants to send data to the host on another network must know the address of the router connected to its own network. In such situation, router solicitation and advertisement message can be held. The host can broadcast or multicast a router solicitation message. The router receiving this message can broadcast their routing information using router advertisement message. Next is different types of messages. ICMPv6. We know that IPv4 was modified into IPv6. Similarly, ICMPv4 is modified with ICMPv6. This new modified protocol is more suitable for IPv6. The ARP and IGMP protocols in version 4 are combined in the ICMPv6. The RARP protocol has been dropped from the protocol suite as it is not used very frequently. Similarly, ICMPv4 messages in ICMPv6 are divided into two classes: error reporting message and query messages. However, each category has more types of messages in ICMP v6 are compared to ICMP v4. Error reporting message. ICMP v6 can handle 5 types of errors. First is destination unreachable, packet is too big, query message, neighbor solicitation and advertisement, time exceeded, parameter problem, and redirection. Note that source quench error message in ICMP v4 can be eliminated in ICMP v6. Packet too big has been newly included. The following 4 messages in ICMP v6 work similar or identical manner as those in ICMP v4: destination unreachable, time exceeded, parameter problem, and redirection. The only different error message is packet too big. So if a packet too big, if a router receives a datagram that is larger than the maximum size of the unit, that is MTU size of the network through which datagram should pass, then two things can happen. The router discards the datagram, and then ICMP error packet, that is packet too big message, is sent to the source originating. Next is query messages. These are additional messages Then ICMP can send after diagnosing some other network problem. Here are 4 different groups of messages have been defined: echo, request and reply, router solicitation and advertisement, neighbor solicitation and advertisement, and group membership. The two types of query messages presented in ICMP v4 have been eliminated in ICMP v6. They are timestamp request and reply and address mask request and reply. First 2 out of 4 groups of messages in ICMP v6 have similar or identical operation as that of ICMP v4. Then the new 2 messages have the different operations. First is neighbor solicitation and advertisement. A network layer in the version 4 contains the ARP, but in ICMP v6 ARP has been eliminated and his duties are included into ICMP v6. The principle has remained the same, but the format of the message is changed. Next is group membership. A network layer in version 4 contains the independent protocol called ICMP, but in version 6 this protocol has been eliminated and its duties are included into ICMP v6. The purpose is same. Next is Unicast routing protocol. The various unicast routing protocols are shown in the full figure. The popular interior protocols are RIP, Routing Information Protocol, and the OSPF, Open Shortest Path First, whereas the exterior protocols popularly used is BGP, Border Gateway Protocol. RIP and OSPF are the upgrading and the routing table inside, and AS and BGP are upgrading the routing tables for the router which joins multiple AS together. Next is RIP, Routing Information Protocol. RIP is used for updating the routing table. The routing updates are exchanged between the neighboring routers after every 30 seconds with the help of RIP response message. These messages are also known as RIP advertisement. These messages are sent by the router or the host. They contain a list of multiple destinations within an autonomous system, that is AS. RIP is an interior routing protocol used inside an autonomous system. It is operation based or the distance vector routing. In the distance vector routing, can each router periodically shares its knowledge about the whole internet with its neighbor. A routing table is every router should keep the routing table. Destination column in the routing table consists of the network address, and the hop counts column consists of the shortest distance to reach the destination, and the next router column consists of the address of the next router in which packet is to be forwarded. The other information may include the information like subnet mask or the time entry was last updated of the time entry was updated. RIP updating algorithm. The routing table is updated when RIP response message is received as stated earlier. The updating algorithm used by RRPs are: RIP response message is received, add one hop and count each advertisement destination. Repeat the following steps each advertisement destination. Add an advertisement information to the table if the destination is not present in the routing table. Replace the entry in the table with the advertisement 1 if next hop field is same. Replace the entry of the routing table if advertising hop count is smaller than 1 in the table. And then finally return. Initializing the routing table. When a new router is added to the network, it's initialize a routing table. Such a table consists of the information only about the directly attached network that corresponds to the hop count. The next hop count field, which identifies the next router, is empty. Updating the routing table. When RIP messages are received, each routing table is updated using RIP updating algorithm. RIP operations. RIP works in the combination of routing database and stores information on the fastest route from the computer to the computer, an updating process that enables each router to tell other routers which route is the fastest from its point of the view, and update the algorithm to update each router to update its database with the fastest route communicated from the neighboring router. Each router internet on the internet keeps the database and stores the following information. First is IP address, the internet protocol address of that computer. Gateway, the best gateway to send the message address to that IP. Distance, the number of routers between the router and the router that can send the message directly to the IP address. Route change flag, a flag indicates that the information has been used to other routers to update their own database. And timer, various timers. At regular interval, each router sends an updating message which has full information about its routing database to all other routers that are directly connected to it. Some routers will send this message often as every 30 seconds so that network will always have up-to-date information. RIP uses the UDP network protocol because it is efficient and there is no problem if a message gets lost due to any reason. This is because the next update will be coming in the short time. RIP message format. RIP message can be broadly classified into two types: message that delivers routing information and message that requests routing algorithm. Both uses same format, which consists of the fixed header followed by the optional list of network and distance pair. So first is command, indicates that whether a type of packet, that is request or response. A request asks a router sends to all packets its routing table, and the response can unsolicited regulated routing update or reply to the request. Response contains a routing table entries, multiple RIP packets used to convey the information from large routing tables. Next is version number. The field specifies the RIP version used, the field that can signal different potentially incompatible version. Next is 0. This field is not actually used by the RFC 105 RIP. It was added just to provide a backward compatibility with the older version of the RIP. Its name is actually indicates its defaulted value is 0. Next is address family identifier. This field is used to specify the address family used. RIP is designed to carry out the routing information for the several different protocols. Each entry has an address family identifier to indicate the types of address being specified. For example, value of the AFI for IP is 2. Similarly, the different value of indicate different protocols. Next is address. This field is used to specify the IP address of the entry. Next is metric. This field indicates the number of hops have been traveled in the trip of the destination. This value between 1 and 15 for the valid route, on the 16 on the unreachable route. Disadvantages of RIP v1. RIP v1 only understand the shortest route to the destination based on the simple count of the number of router hops. It depends on the other router for computed routing updates. Routing tables can get large and these are broadcasted every 30 seconds. Distance are based on the hops, not on the real cost, such as the speed of link. It continues to be router to router configuration to means each router is fully dependent on its next router to implement the same option. If we solve the problem, other appears. RIP version 2. In November 1994, RIP was modified with some addition extension to overcome some of its shortcomings. RIP version 1 is still being used and many routers and continues outnumbers of OSPF network. The modified RIP is called as a RIP version 2 protocol. Version 2 is backward compatible with version 1 and contains all compatibilities of the version 1 protocol. RIP version 2 implemented the following features. First is authentication by means of the simple text password. Second is subnetting masking used. Third is multicasting used to allow a variable length of subnet mask to be implemented. Next is root tag to provide a method of separating RIP root from externally learned router. Next is compatibility switch to allow the interoperability between the version 1 router. Notice that some features format is same as the RIP v1 to RIP v2. Next is OSPF routing protocol. This is another interior routing protocol. It is an intra-domain protocol. It is based on the link state routing for handling the routing efficiently and in timely manner. The OSPF divides in an AS into the areas. Area, network host and routers are collectively called as an area. An autonomous system can be imagined to be made up of various areas. All the networks inside an area should be connected. Area border router. These are special types of router which are used to be border of an area. Backbone. A special area inside an autonomous system is called as a backbone. All the areas inside the AS should be connected to the backbone. So the backbone is the primary area and other areas are known as the secondary area. Backbone routers. The routers inside the backbones are called as a backbone routers, but the backbone routers can also be called as a area border routers. Area identifier. Each area has an area identification. The area identification of the backbone is the 0 and the autonomous system. Next is features of the OSPF, types of service routing. It is possible to configure a different routers to support a different types of services requirement. For example, one router can be configured for higher throughput while the other one is configured to support minimum delivery delay for some other application. Load balancing. When the multiple routers are available, traffic can be evenly distributed over the routes. This would obviously result into higher network efficiency. Third is subdivision of autonomous system. It is possible to further divide into system into the logical areas. This would be improved the management of the large autonomous system. Fourth is security. The data exchange in the OSPFs are authenticated. Inadvertent or the malicious transmission from the foreign routing nodes are discarded. Only those hosts are intended for the routing networks are included. The network isn't vulnerable to threat of having routing table corrupted by faulty route information. Fifth is host. OSPF supports specific network and subnetworking routes. Next is special features are provided to support LAN environment. Although the relationship between the routers are maintained on the logical link basis, the link state transmission are minimized by architecture. Design gateway are responsible for transmission of the link state information for information in their local areas. Seventh is OSPF is open specification. The OSPF has the publish an RFC and not defined as the de facto standard such as RIP. Therefore, anyone can implement the standard without paying royalties. This has been done to encourage many vendors to use it so that users does not lock into the single vendor's equipment. Next is OSPF area. OSPF divided in the network into groups called an area. The topology of an area is not known to the rest of the autonomous system. This technique minimizes the routing traffic required for the protocol when the multiple areas are used. Each area has its own copy of the topological database. Several concepts have been incorporated in the OSPF algorithm. The RIP treated an autonomous system as a monolithic collection of the routes and subnets, but the OSPF introduced the concept of areas. The concept of hiding routing information within an OSPF routing domain, Internet Autonomous System, has also been introduced. After dividing an autonomous system into the collection of logical areas, the OSPF can support the different types of routing nodes that are routers such as internet routers, area border routers, backbone routers, and autonomous system boundary routers. The protocols used for support OSPF routing includes the database broadcast packets and the link state change broadcast. A hello protocol is used to detect the change in the availability of the adjacent routers. Next is OSPF packet format. All OSPF packets have the same command header. In all the 5 packet type of OS, various fields in the OSPF packet headers are follows. First is version. This contain 8-bit field tells us about the version of the OSPF protocol. It is currently version 2. Next is type. This is 8-bit field defines the type of packet. There are 5 types of OSPF packets. They can define by adjusting the content of the type field from 1 to 5. The OSPF makes 5 different packet types. First is hello packet, used to discover and maintain neighbor. Next is database description, used to form adjacencies. The router summarizes all link state advertisement and passes the information via database description packet to the router, with which it forming an adjacency. Next is link state request. After the database description packet have been exchanged with the neighbor, the router may think that link state advertisement it requires to update or complete the topological database. Link state request packets are sent to neighbor in order to request for the link state advertisement. Next is fourth packet is link state update. It is used for the transmission of the link state advertisement between the routers. This could be response to link state request packet or flood to new or more recent link state advertisement. And last type of packet is link state acknowledgement. It is used to make the flooding of the link state advertisement reliable. Each link state advertisement received is explicitly acknowledged. Next is message length or the packet length. This is 16-bit field, defines the length of the total message, which includes the header as well as the body. Next is a source router IP. This is 32-bit, defines IP address of the router that sends the packet. Area identification or area ID. This is 32-bit field, defines the area within which the routing takes place. Next is checksum. This field is used for the error detection on the entire packet, excluding the authentication type and authentication data field. Next is authentication type, that is AU type. This is 16-bit field, defines the authentication method used in the area. At this time, 2 types of the authentications are defined. A0 in this field shows the no authentication being used, and 1 represents the password for the authentication. Next is authentication. This is 64-bit field, is actual value of the authentication data. In the future, when more authentication type would be defined, this field will contain the result of the authentication calculation. For now, if the authentication type is 0, the field is filled with 0, and if the type is 1, then the field carries the 8-character passwords. Next is border gateway protocol. BGP is an exterior routing protocol. It is Unicast routing protocol. It is used for the inter-autonomous system using routing among different AS. It was introduced in 1989 and has 4 versions. BGP operation takes place on the basis of the routing method called as a path vector routing. This principle is used because the distance vector routing and link state routing do not prove to be much suitable for inter-autonomous system routing. Path vector routing, it is different from the both distance vector and link state routing. The autonomous boundary router participates in the path vector routing. Their job is to advertise the reachability of the network present into their autonomous system to neighbor autonomous boundary router. Each router that receives a path vector message verifies whether or not to be advertised a path is accordingly to its policy. Such a policy is made up of rules and are imposed by the router controlling administrator. If yes, then the router will update its routing table and will modify the message before it is sent to the next neighbor. In the modified message, it sends its own AS number and replaces the next router entry with its own identification. Next is how BGP operates. BGP performs 3 types of routing: inter-autonomous system routing, intra-autonomous system routing, and pass-through autonomous system routing. Inter-autonomous system routing would take place between 2 or more BGP routers in different autonomous system. Peer router in this system use the BGP so that they can maintain a consistent view of the internetwork topology. BGP neighbors communicating between the autonomous system must be member of the same physical network. The internet serves as an example of the entity that use this type of routing because it is made up of autonomous system or the administrative domain. Many of this domain corresponds to the various institutions, corporations and entities that makes up the internet. BGP is frequently used to determine the path which results in the optimal routing within the internet. Intra-autonomous system routing takes place between two or more BGP routers that are located within the same autonomous system. Peer router with within the same autonomous system uses the BGP so that they can maintain the consistent view of the system topology. BGP also used to determine which router will serve as the connection point for the specific external autonomous system. Once again, the Internet itself is the example of inter-autonomous system routing. An organization such as university could make the use of BGP to provide optimal routing within its own administrative setup of the autonomous system. The BGP protocol can provide both inter and intra-autonomous system routing service. The pass-through autonomous system routing takes place between two or more BGP pair routers for that exchange of traffic across an autonomous system that does not run BGP. In pass-through autonomous system environment, the BGP does not deal with the traffic that originates within the autonomous system in question and is not destined for the node in the autonomous system. BGP must interact with whatever intra-autonomous system routing protocol is being used to successfully transport BGP traffic through the autonomous system. How the BGP solves the count to infinity problem. The BGP is basically a distance vector protocol, but it is very much different from the most other protocols such as RIP. Instead of maintaining just cost of each destination, each BGP router keeps the track of the path used. Similarly, instead of periodically giving a neighbor its estimate cost to each possible destination, each BGP router tells its neighbor the exact path of that it is using. A BGP router shows the information that router is receiving the neighbor's information about. BGP can solve the count to infinity problem easily. This can explain as follows. Suppose the router G crashes, or if the line FG becomes faulty, then the router F receives the routes from remaining three neighbors, that is BIE. These are the routes are BCD, IFGCD and EFGCD. So looking at this routing paths, the router F immediately understands that the route IFGCD and IFGCD are useless because they pass through the F itself. So it decides FBCD path as a new path to avoid the count to infinity problem. Thank you.